The spatial arrangement or stereochemistry of alkenes can be altered by light. Cis-stilbene, and that's the non-IUPAC name, can be changed into trans-stilbene by rotation of the double bond through 180 degrees, a one-bond flip. While cis-stilbene is only 21 kilojoules per mole higher in energy than the trans conformation, the energy barrier to go from trans to cis is 259 kilojoules per mole. This excludes such rotation without breaking and reforming the pi bond. But this relates to the ground state S0, where the highest occupied molecular orbital, HOMO, is the pi orbital that contains 2 electrons, and the lowest unoccupied molecular orbital, LUMO, is pi star antibonding orbital with no electrons. Should the trans-stilbene be exposed to ultraviolet light, the molecule can enter an excited state, where the HOMO pi orbital has 1 electron, whilst the other electron that was in the same orbital with the extra energy has moved into the originally LUMO pi star antibonding orbital. The former double bond is now longer in the S1 state, and 6% of it in the excited state S1 with the dihedral angle of 180 degrees returns via fluorescence to the trans-stilbene. An equal number of bonding and antibonding electrons cancel each other out, and thus with 1 pi electron and 1 pi star electron, the pi bond is cancelled out, and now the former double bond can rotate about the sigma bond. 94% of the molecules carry out this rotation and diminish the dihedral angle. Cis-stilbene, when exposed to ultraviolet light, also absorbs the photon and goes from being in the ground state of S0 to the excited state S1. With the S1 excited state having a dihedral angle of 0 degrees, only 0.1 of those molecules will fluoresce to return to the cis-stilbene S0 ground state. 30% of them carry out an electrocyclic rearrangement that's not discussed here, and just 70% exploit the ability of the sigma bond to rotate, thus increasing the dihedral angle. Both the 0 degree and 180 degree dihedral angle S1 excited states relax through rotation about the sigma bond to lose energy until they reach the common transition state twisted configuration with a dihedral angle of 90 degrees. This has 444 kilojoules per mole more energy than the trans-stilbene S0. Using internal conversion, IC, this excited transition state is converted into the ground state S0 with a dihedral angle of 90 degrees. Now, half of those molecules lose energy to become the cis-stilbene, whilst the other half of the molecules lose energy to become the trans-stilbene. This has addressed the singlet method for interconversion of cis and trans-stilbene without a sensitizer. The intersystem crossing, ISC, to allow the triplet pathway here is inefficient.